Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. File systems define how data is stored, organized, and accessed on a storage device. Every operating system depends on a file system to manage its files, track used and unused space, and support user operations like saving, copying, or deleting. Each operating system prefers a different default file system, and these choices affect performance, compatibility, permission handling, and maximum file size. In some cases, choosing the wrong file system can prevent a drive from working across platforms or limit the types of files it can store. The A+ Core 2 exam includes questions on file system types, their use cases, and how to format or troubleshoot them. One of the most important file systems for technicians to recognize is NTFS, which stands for New Technology File System. This is the default file system for Windows internal drives. NTFS supports large files and volumes, advanced file permissions, encryption, compression, and disk quotas. It also includes journaling, which helps protect data from corruption in the event of a system crash or power failure. NTFS is used on nearly all internal Windows drives and is the preferred choice when security and recoverability are important. exFAT, short for Extended File Allocation Table, is commonly used for flash drives, external hard drives, and SD cards. It was designed to overcome the limitations of FAT32 while remaining simple and compatible across platforms. Unlike NTFS, exFAT does not support file-level permissions or journaling, but it does support much larger file sizes than FAT32. This makes exFAT a good choice when transferring large video files or backup archives between Windows, macOS, and Linux systems with the right drivers installed. FAT32 is an older file system that still appears in specific scenarios. It supports a maximum file size of 4 GB and a maximum volume size of 2 TB. Because of its simplicity, it is still used for UEFI boot partitions, BIOS-compatible flash drives, and small removable media. It is nearly universally supported across all major operating systems, which makes it useful for compatibility. However, the size limits and lack of modern features make FAT32 unsuitable for modern storage tasks beyond temporary use. ext4, or the fourth extended file system, is the default for most modern Linux distributions. It supports journaling, file permissions, and very large volume sizes, making it ideal for both personal and server environments. ext4 is not natively readable by Windows or macOS, although third-party drivers and utilities can enable limited access. ext4 is used in firewalls, lab setups, application servers, and development systems. Linux tools such as MKFS and FSCK are used to format and repair ext4 file systems as needed. APFS, or Apple File System, is the default file system for modern macOS and iOS devices. It is optimized for solid-state drives and includes support for snapshots, file-level encryption, and fast directory sizing. APFS replaced HFS Plus as Apple's default file system in macOS High, Sierra, and later. It is designed for speed, reliability, and space efficiency. Apple mobile devices, including iPhones and iPads, also use APFS to manage their flash storage, ensuring consistency across the Apple ecosystem. HFS Plus, sometimes written as HFS Plus, is Apple's legacy file system. It was used before the adoption of APFS and is still supported in Mac OS for backwards compatibility. While it offers basic journaling and volume management, it lacks many of the modern features found in APFS. Some older external drives and disk images may still use HFS Plus. Technicians supporting Apple environments should be able to identify whether a volume is formatted with HFS Plus or APFS and understand the limitations of each. Permission support varies between file systems. NTFS, ext4, and APFS all support access control lists, or ACLs, which define which users or groups can access specific files or folders. This is essential in enterprise and multi-user environments where file security is important. In contrast, exFAT and FAT32 do not support permissions or user-level access controls. These file systems are not suitable for situations where secure access needs to be enforced at the file level. Each operating system includes built-in tools for formatting drives. In Windows, you can use the Disk Management tool or the Format command in Command Prompt. Linux uses tools like NTFS and gparted to create and manage file systems. macOS provides disk utility for graphical formatting, or diskutil from the command line. These tools allow technicians to format drives to the appropriate file system for the environment. Understanding which tool to use and which options to select is critical for preparing drives for deployment. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Different file systems are optimized for different use cases. NTFS is best for internal Windows drives where you need support for permissions, encryption, and large file sizes. exFAT is ideal for external storage devices that need to be shared between multiple operating systems, such as flash drives or external hard drives. ext4 is the go-to choice for most Linux installations and servers due to its stability and flexibility. APFS is preferred for Apple devices using solid-state drives, including MacBooks, iPhones, and iPads. Matching the file system to the environment ensures compatibility and stability. Boot support also depends on the file system being used. Most UEFI systems require a boot partition formatted as FAT32, even when the main operating system partition uses a different format. Windows typically boots from an NTFS partition. macOS boots from APFS. Linux bootloaders can reside on an ext4 partition, though they may still use a small FAT32 boot partition for compatibility. Understanding boot requirements is important when creating installation media or troubleshooting systems that won't start properly. Cross-platform compatibility can be a major challenge when transferring files between systems. Windows supports reading and writing to NTFS and exFAT. macOS can read NTFS but cannot write to it without third-party tools, while it supports exFAT natively. Linux supports all major file systems, but may require mounting and additional drivers to access NTFS or APFS volumes. Technicians must choose the appropriate format based on the systems involved in the transfer. exFAT is often the most universal choice for cross-platform data sharing. Here is a typical scenario that appears in both support roles and the A+ exam. A user wants to transfer a 10 GB video file between a Windows laptop and a Mac. If they format the flash drive with FAT32, the file will not copy due to the 4 GB file size limit. Formatting the drive with exFAT resolves the issue, as both systems can read and write to it, and it supports larger files. Alternatively, using NTFS would require extra drivers on the Mac, making exFAT the simpler solution. Journaling is a feature that helps protect data integrity. It works by recording changes in a log before committing them to the file system. If a crash or power loss occurs during a write operation, the system can use the journal to restore consistency. Journaling is found in NTFS, ext4, and APFS. It is not present in exFAT or FAT32. This makes journaling file systems safer for critical systems or frequent write activity. Systems without journaling are more prone to corruption after an unexpected shutdown. File and partition size limits vary significantly between file systems. NTFS and APFS support multi-terabyte volumes and individual files up to several terabytes in size. ext4 also supports extremely large volumes, with a theoretical limit of 16 terabyte files and exabyte level volumes. FAT32, by comparison, limits individual files to 4 gigabytes and partitions to 2 terabytes. exFAT supports larger files but may not match the full limits of NTFS or APFS. When choosing a file system, these size limits are a major factor. Naming conventions and case sensitivity also differ. NTFS is case insensitive by default, but preserves case for appearance. That means file.txt and file.txt are treated as the same file. ext4 and APFS by default are case sensitive. On those systems, the same two file names would refer to separate files. macOS can be configured for case-insensitive or case-sensitive behavior depending on how the volume is formatted. Understanding these naming behaviors is essential when transferring files or writing scripts that reference file names. Tools exist to convert or reformat file systems, although options and limitations vary. In Windows, you can convert a FAT32 volume to NTFS using the convert command. This preserves data, although the reverse is not possible without reformatting. In Linux, tools like gparted or mkfs are used to format or set up partitions. However, converting ext4 to another format typically requires backing up data, formatting, and restoring files. In macOS, disk utility allows technicians to reformat drives and switch between APFS and HFS+. Always back up data before reformatting. File system errors can prevent access to files or corrupt system data. On Windows systems using NTFS, the chkdsk tool scans for logical and physical disk errors. In Linux, the fsck tool is used to scan and repair ext4 volumes. In macOS, disk utility includes a tool called First Aid, which checks and repairs APFS or HFS+ volumes. These utilities are critical when resolving startup issues, detecting hardware faults, or troubleshooting unexplained system slowdowns. To summarize, technicians must choose the correct file system for the operating system, hardware, and intended usage. File systems like NTFS, exFAT, ext4, and APFS each offer different features, size limits, and compatibility profiles. You must understand how these formats behave, what tools are used to manage them, and how to diagnose issues when they arise. The A+ exam frequently tests this knowledge through matching questions, formatting scenarios, and problem-solving situations where choosing the right format ensures successful deployment or data transfer. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.